All right, guys, we are going to start our discussion of solutions. Now, by the end of this, you will be able to differentiate between what is a solvent and what is the solute, as well as determine which compounds are soluble or insoluble using Table F of your reference tables. Okay, so let's get started. What is a solution? Well, in chemistry, a solution is simply a mixture. It's a homogeneous mixture of two or more substances. So if you were to put salt into a glass of water and stir it, you'd end up with salt water. That's a solution. It's a homogeneous mixture of salt and water. Once they're combined, everywhere in the container, you're going to find both salt and water. Fair enough? Okay. However, the terms salt and water are going to be a little bit different from here on in. Meaning, the terms we use for the salt and water are going to be a little bit different from here on in. Let's start with solute. The solute, in the example I just gave you, would be the salt. It's whatever substance is dissolving in the liquid. So in the previous slide, it was salt into water. If you have coffee or tea, perhaps in the morning, and you put sugar into it, and you put the sugar in and you stir it around, and the sugar dissolves, the sugar is the solute. Okay, it's the substance that is dissolving. However, you're placing these substances into a liquid, and from here on in, we're going to call those liquids solvents. Those solvents are what are dissolving the salt or the sugar, right? They're dissolving the solutes. Water is a great example of a solvent. Water dissolves lots and lots and lots of different things. But that coffee or tea that you're having in the morning, those are solvents too, because the sugar, the solute, is dissolving in the tea, the solvent. All right? So, the solute is the substance that dissolves. And there's lots more than just sugar and salt, but these are two examples I'm sure you're pretty familiar with. The solvent, on the other hand, is the substance that does the dissolving, and it's oftentimes a liquid. Okay? So let's take a look at a question. In an aqueous saltwater solution, what is the solute? Is it A, the salt, or B, the water? Well, if you said A, the salt, you are absolutely right. Because remember, the solute is what dissolves. Okay? So, solute, solvent. Now there are two more terms we're going to have to talk about, and these will be the last two new vocabulary words for this discussion in solutions. And the first one is soluble. Now when the salt went into the water and it dissolved, right? That salt was soluble because it was able to dissolve in the water. So any substance, or the solute I should say, that will dissolve in the solvent, that substance is soluble. So salt is soluble in water. Sugar is soluble in tea. But then what would be the opposite? What term do you think we might use for a substance that won't dissolve? Those substances we call insoluble. Those are substances that, mixtures where the solute will not dissolve in the solvent. So in this animation here, actually, you're looking at oil, that's the kind of the brown stuff, in a container of water. And I'm sure you know that oil and water don't mix, right? So if you notice, the oil is kind of keeping to itself. It's creating these little spheres of oil within the container of water. So the water and the oil are completely separate from one another. So we can say that oil is insoluble in water. All right? Soluble, the solute will dissolve. If it's insoluble, it will not dissolve. And here's just another picture to show you. These are 2 beakers of water. On the left, we have a soluble compound, because see how the green has completely mixed with the water. And on the right, we have an insoluble compound, because as you can see, they're separating, right? There's 2 separate layers. The water is on the bottom, and the insoluble compound, which happens to be olive oil, is sitting or floating on the top. Okay? Soluble on the left, insoluble on the right. So let's take a look at a question. Which term describes a solute that does not dissolve in a solvent? Is that term A, soluble, or B, insoluble? Well, if you guess B, you are correct. If the substance will not dissolve, then it is insoluble. And I'm sure you can think of things around your home that might be insoluble, like salad dressing, right? Before you put salad dressing on your salad, you have to shake it up to get the oil and the vinegar to mix, so that when you pour it out, you get a little bit of both. But when you put the salad dressing back on the counter, the oil and the vinegar separate out again. Even if you don't eat salad, I'm sure you've seen that. Anywho, here's the question. Let's say you're given chemical formula or molecular formula. How can you tell if that substance is soluble or insoluble? How would you know if that substance would dissolve in water, for example? Well, one of the easiest ways to do this for you guys is to use your reference tables and to take a look at Table F. Table F is the reference table titled Solubility Guidelines for Aqueous Solutions. So these are solubility guidelines for solutions mixed with water, right? Because that's what aqueous means. So here's Table F just a little closer up so you can really kind of see what we're looking at. Now, if you notice, there are 2 boxes. One box on the left here, and then another box on the right. Now, this box on the left lists ions that form soluble compounds. So here there it is. Here we have a whole list of ions that form soluble compounds. Now notice there are a couple of exceptions. We'll talk about those in just a minute. Now the box on the right lists ions that form insoluble compounds, and these also have exceptions, but we'll discuss that again in just a minute. So I think the easiest way for us to really get to know Table F is to use it. So what we're going to do is together we're going to practice looking at some compounds and determining whether or not they're soluble or insoluble in water according to Table F. Okay, so let's just jump right in. And we're going to start with sodium chloride, right? General, regular old table salt. Now, my guess is you already know what the answer to this question is, but let's use table F to be sure. So, if you look at table F and you look at the left box of table F, you'll see it lists group 1 ions, like sodium here, right? It lists that these group 1 ions are in fact soluble. And notice there are no exceptions here. So, no matter what, these group 1 ions are soluble. So, if that's the case, sodium chloride is soluble. Now, you could also look a little further down the chart here where it says halides, and notice that chlorine is considered an ion that forms soluble compounds. And I hit the check a little early, sorry about that. But here we have chlorine as an ion that forms soluble compounds. But notice the exceptions, right? Sodium isn't listed as one of the exceptions. So, since chlorine forms soluble compounds and sodium forms soluble compounds, the whole thing is soluble. Okay? All right, let's take a look at another one. We're going to do a few, so maybe it'll be a little more understandable. How about silver bromide? So, let's take a look at table F, right? We're looking at silver and bromine. If you look in table F and you kind of scroll down to where it says halides here, notice bromine is listed in the column of ions that form soluble compounds. However, there is an exception. So bromine will form a soluble compound except when it's combined with one of these elements, one of these ions. And notice that silver is here. So bromine is soluble except when combined with silver. And since we're looking at bromine and silver together, this compound is not soluble. Okay? So the bromine normally would be, except when it's combined with silver. All right, let's take a look at another one. Here we have calcium carbonate. Is calcium carbonate soluble? Well, let's take a look at table F. Now, calcium, now remember we're looking at calcium and then the carbonate ion. If you look here in table F, it says that carbonate ions form insoluble compounds, except when they are combined with either group 1 ions or ammonium. Now here we have carbonate combined with calcium, and calcium is a group 2 element. So because of that, carbonate is insoluble. So the entire compound is not soluble. It's insoluble. And again, carbonate ions, according to table F, are insoluble, except when they're combined with group 1 ions, like lithium, sodium, potassium, or if they're combined with ammonium. But in this situation, our insoluble carbonate ion is not combined with any of those. So, as a result, the whole thing is insoluble. All right, let's do just one more. Whew, that looks like a big one, right? Well, don't fret, because we're going to look at this compound. We're going to kind of look at it in pieces, right? Here we have NH4 and we have S. So if we look at table F, the right box lists sulfide ions as forming insoluble compounds, right down here. They form insoluble compounds, except when they're combined with ammonium, NH4. So look up here. Here we have sulfur, which would normally be insoluble, except when combined with ammonium, which is right here. So because it's combined with the ammonium, this is absolutely a soluble compound. Okay? So, what I'm going to ask for you guys to do, hopefully right now while it's still fresh in your mind, is I'm going to ask you guys to go to Google Classroom, and right next to where this PowerPoint is posted in Google Classroom, there's a link to an exit ticket. It's a Google form titled Exit Ticket Table F. Click on that and it's going to take you to a Google form with 5 questions where you're going to determine, using Table F, if the compound listed is soluble or insoluble. And I just ask that you do your best, okay? If you have any questions, you can email me. You can leave them in the stream section on Google Classroom, or during the 20 minutes when our class is scheduled to meet according to the schedule you got from in an email from John Dewey. During those 20 minutes, I will be available live to answer your questions on Discord. And I've left instructions on how to get in touch with me on Discord in Google Classroom, and I've also emailed them to you. Okay, so that being said, have a great night, and I'll see you tomorrow. Be well.